Great, it's recording now. Section 7.2 deals with sum and difference identities. Savannah, welcome. How are you doing? Everything okay? Welcome. We just started. We're gonna talk about sum and difference identities. Welcome, Savannah. Welcome. Okay, great. So mathematicians have figured out formulas to deal with trigonometric functions of the sum or the difference of two angles. First, we will cover the ones related to sine and cosine, and then we will talk about the ones related to tangent, okay? All right, so welcome, Cam. We just started. So we were just saying that mathematicians figure out formulas to deal with trigonometric functions of the sum or the difference of two angles. And the first one is this. It says sine of alpha plus beta equal sine of alpha times cosine of beta plus cosine of alpha times sine of beta. Okay. Welcome, Lucero. We just started. Second formula says sine of alpha minus beta equal to sine of alpha times cosine of beta minus cosine of alpha times sine of beta. These two formulas are intuitive. Let's write it here. Intuitive. In the following sense, look, plus here, you expect a plus here, appears here, right? Minus here, you expect minus, minus appears there. So very intuitive, easy to remember. Now, let's talk about the ones for cosine of the sum or the difference of two angles. Cosine of alpha plus beta turns out is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Minus, professor, is that a typo? No, guys, it's not a typo. It's just that these formulas for cosine are counterintuitive, right? You expect there a sign that is positive, right? But indeed is negative. Similarly, look, the next formula, cosine of alpha minus beta equal cosine of alpha times cosine of beta plus sine of alpha times sine of beta. Plus, professor, is it a typo? No. It's just that the formula is counterintuitive. I know, guys, you expect a minus here, but mathematicians have proven that indeed is a plus. So we're gonna write here counterintuitive, right? For you guys to remember, right? So good. Now we're gonna use these formulas a lot. If you can memorize them, fine, but if not, not a problem because they come together with the unit circle sheet here, right? And at this point, you might have this sheet already, okay? It's among the, or below course materials under useful sheets, but if you don't have it, here it is. I'm gonna put it in the link right now. This is a very important sheet. There you go. You just click in there, you will have access to it. Print it out, have it ready for your final exam, okay? Which is gonna be this Thursday night or Friday, anytime, right? We'll talk about it later. Yeah, so have it ready because here is where the formula is. Look, sum and different identities. Sine of x plus y equals sine of x cosine y plus cosine of x sine y, the first formula. Second formula, sine of x minus y, sine of x cosine y minus cosine x cosine y. Third formula, cosine of x plus y equal cosine of x cosine y minus sine of x sine y. Last formula, cosine of x minus y equal cosine of x cosine y plus sine x sine y, right? The four formulas are summarized there, okay? Here. These are the formulas. So now let me show you how to use these formulas, right? For example, one says, find the exact value of sine of 75 degrees. Using the fact that 75 degrees is the sum of 45 degrees plus 30 degrees, or 30 degrees plus 45 degrees, doesn't really matter. All right, let's do that together. So, solution, sine of 75 degrees, following this fact, can be computed as follows. Sine of 45 degrees plus 30 degrees, right? And you may say, Professor, why you are breaking this down? Well, I'm trying to write this as a sum because I have formulas for the sum of two angles when it comes to compute the sine function, right? And also because they are asking me for the exact value, meaning the one that contains the radicals, the fractional part, right? Because of that. Right? Otherwise, I can just put it in the calculator, but it's going to give me like a decimal value, right? So let's do it together now. This form. So sine of 45 plus 30 degrees is going to be the following. If I let this 45 degrees play the role of alpha and this 30 degrees play the role of beta, right? I can apply then this formula, right? The first formula. So this will be equal to what? Sine of alpha, but alpha we're saying is 45 degrees. Multiply by cosine of beta, but beta we're saying is 30 degrees, right? Very intuitive formula, plus. Then cosine of 45 degrees, right? Cosine of alpha times sine of beta, but beta is 30 degrees, right? So look how we broke this down. Now, we just gotta recall what is each of these guys now. Sine of 45 degrees, you can check on your unit circle sheet here at 45 degrees and look at the second coordinate, right? Second coordinate is square root of 2 over 2. That is sine of 45 degrees, right? So you can get it from there. 45 degrees is square root of 2 over 2. Or if you have memorized this, also you can just retrieve it from your mind, right? Great. Now, cosine of 30 degrees, Back to the unit circle. 30 degrees here, you look at the second coordinate, but that sine, the first coordinate now will be cosine, right? So we're talking about a square root of 3 over 2, right? A square root of 3 over 2, cosine of 30 degrees, right? Cosine of 30 degrees. A square root of 3 over 2. Great. Plus cosine of 45 degrees. Anyone could tell me by looking at the unit circle or by remembering this as a fact, what is cosine of 45 degrees in the chat? Or verbally, cosine of 45 degrees. I see. Very good, Kang. Excellent. Very good. I'm glad you're tuned and great. It's just here, right? Cosine of 45 degrees. You look at the first coordinate, square root of 2 over 2, right? Excellent. It's the same as sine. It's a special angle, right? Yeah, square root of 2 over 2. And anyone could tell me sine of 30. What's that? Either from your mind, if you have memorized this result, or from the unit circle, sine of 30 degrees. Remember sine, second coordinate, right? You gotta look at the second coordinate of 30 degrees on the unit circle. Excellent, Savannah. Yeah, very good, very good. Very good, Khan. Very good, Savannah. Excellent, guys. Right? We just have to look at 30 degrees, but now we gotta pay attention to the second coordinate. The second coordinate on the unit circle gives you sine. Okay, great. So this is 1/2. And that basically, that is it, because then you just have to multiply these two radicals, right? A square root of 2 times a square root of 3, remember, is just a square root of 2 times 3, 6, right? That's how you multiply the radicals. Over 2 times 2, denominators multiply, they give me 4, right? 4, very good. Plus, a square root of 2 times 1, a square root of 2, square root of 2, over 2 times 2, 4, right? Great. Now, this could be considered to be the answer, okay? But mathematicians, remember, often like to put things together, so we can do this. Since the denominators are the same, equal to 4, common denominator goes here, 4, and we just add the numerators, right? So this should be it. This is a good way to present the answer in exact form, right? In exact form. But turns out it's not the only way. It's not the only way. I'm gonna write here, or equivalently. Sometimes mathematicians like to factor things out, right? Factoring out. Sort of the greatest common factor here is square root of 2, because it's here embedded, right? So if you do that, then you will get the following. A square root of 2 outside, a square root of 2 into a square root of 6 is just 2 into 6 is 3, right? So it's square root of 3, plus a square root of 2 into itself, just 1, right? 1. And the denominator stays the same. So these two presentations are equivalent. So be aware of that, guys. Sometimes on the multiple choices, you will see this, but sometimes you may see this. So be aware they are the same, okay? They are the same. Very good, guys. So now let's practice, right? Let's practice. Let's start with the first one here. What about doing this? Can you try this? I will give you the formula, okay? Number 1. It says find the exact value of this expression, okay? Cosine of 60 degrees plus 45 degrees. Hint, cosine of alpha plus beta. We explain it's counterintuitive. If this cosine of alpha, cosine of beta, you expect plus, but in reality it's minus. Minus sine of alpha, sine of beta. Use this formula, guys. Let this play the role of alpha. Let this other angle 45 play the role of beta, and apply, use this formula and try to figure out what is cosine of 60 degrees plus 45 degrees in exact form, okay? Exact form. Go ahead. Welcome, Shuyi. I didn't welcome you, so good. We are covering the last part of the course, right? There's some additional topics, so you will be ready for your final. Yeah, I use the unit circle to pull out the values, right, of cosine, sines of 60 degrees or 45 degrees. I see someone figured this out already. Savannah, very good. Yeah, you made my day, Savannah. Excellent, excellent. Very good. Yeah, so this should be equal to what? It should be equal, according to our formula for the cosine of the sum of two angles, it should be equal to cosine of alpha, but alpha is 60 degrees, cosine of 60 degrees, multiplied by cosine of beta, but beta is 45 degrees, so cosine of beta, cosine of 45 degrees, minus sine of alpha, alpha 60 degrees, sine of beta, beta 45 degrees. This is it, right? And what is left is just to get the values here. Cosine of 60 degrees, very good, excellent, you got it. Yeah, cosine of 60 degrees, if you look at the unit circle, is a square root of 3 over 2. Professor, how you memorize that? Yeah, yes, I did, because I work with this a lot. So, but if not, if you forget, you want to check, double check, it's here. 60 degrees, you look at, yeah, actually, this will be 1/2 because it's the first coordinate, right? We're dealing with cosine. Yeah, I was still thinking on the previous formula. So this is 1/2. Making sure. Yeah, great. 1/2, right? Cosine of 60 degrees. Now, cosine of 45 degrees, we just saw that it's the square root of 2 over 2, right? Square root of 2 over 2. So we memorize it. Yes, I did. But in case you want to double check or make sure, you go to the sheet or unit circle, it's there. is the first coordinate here, square root of 2 over 2, right? There we go. Then we have sine of 60 degrees. This is the one that I wrote here, square root of 3 over 2, right? Square root of 3 over 2. This is it, minus here. Where is that in the unit circle? Here, 60 degrees. Second coordinate is sine, square root of 3 over 2. And the last one, sine of 45 degrees is the same as sine of, as cosine of 45 degrees, square root of 2 over 2, right? The rest, guys, is just computational. 1 times the square root of 2 is square root of 2 over 2 times 2, 4, minus minus a square root of 3 times the square root of 2 is square root of 3 times 2, 6 over 2 times 2, 4, right? And pretty much this is it, because now common denominator 4 here, and on the top is square root of 2 minus square root of 6, right? This would be a very good way to present the final answer in exact form. And indeed is there, right? They didn't go over the factorization, right? So that's it. Very good, guys. So now, let me show you another one. Can you try one? Maybe this one, cosine with minus. Yeah, cosine of 45 degrees minus 30 degrees. Hint here, formula. A cosine of alpha minus beta. It is counterintuitive. Remember, cosine is equal to cosine of alpha, cosine of beta, minus, you expect minus, but indeed it's plus sine of alpha, sine of beta, right? Professor, where is this formula? Well, it's in the unit circle sheet in the bottom, right here. Here I show you, right? It's here. I'm using this. Look, cosine of x minus y equal cosine of x times cosine of y plus the bottom sign with the bottom sign, right? Plus sine of x, sine of y, right? Follow, guys? Yeah, it's there. The formulas are going to be there. Yeah, so go ahead and apply this formula, right? And figure this out in exact form, right? In exact form. Exact form. Yeah, let this 45 play the role of alpha. Let this 30 degrees play the role of beta, right? Substitute there in your formula and figure out the right answer for this number 2. And you can use your unit circle, right, to figure out the cosine of 45 degrees, the sine of 45 degrees, in case you have not memorized them, right? It's okay. Aha, very good, very good. Savannah and Khan, excellent, good guys. Yeah, you got it. Yeah, we just follow the formula, right? Cosine of 45 degrees times cosine of 30 degrees, right? Counterintuitive, the formula for cosine, so this is plus sine of 45 degrees, sine of 30 degrees. And then let's just recall what we got before, right? What is cosine of 45 degrees? It's just the square root of 2 over 2, right? We got them before from the unit circle here, right? There in the unit circle. Cosine of 30 degrees now. Cosine of 30 degrees is a square root of 3 over 2. Can we double check, Professor? Yes, of course. Cosine of 30 degrees, you see here, 30, you look at the first coordinate, is square root of 3 over 2, right? It's there. Great. Now, plus, sine of 45 degrees, very easy, right? It's just this guy, square root of 2 over 2. Sine of 30 degrees, also easy, 1/2, right? If you forgot for some reason, you can always find it here. Second coordinate, 1/2 of 30 degrees. Great. Now, just combining these two or multiplying these two, there's a square root of 2 times the square root of 3 is square root of 6 over 2 times 2, 4, plus a square root of 2 times 1 is square root of 2 over 2 times 2, 4. And finally, mathematicians like to put them together as this: a square root of 6 plus a square root of 2 on the top over 4 common denominator, right, on the bottom. That's it. And this is this guy. Excellent. Now, I show you another form. I show you that sometimes mathematicians may factor this square root of 2, right? Let me give you an example where that happens, okay, for you to be aware. This you can do at home. You can do at home. This we did already in an example. This one, try this one, okay? Try to compute sine of 15 degrees, but I'm gonna give you this hint: 15 degrees is equal to 45 degrees minus 30 degrees, right? Use this fact. So use this: sine of 45 degrees minus 30 degrees. Professor, why did you write this 15 as a difference? Well, because we have this formula, sine of alpha minus beta, right? And that is equal to sine of alpha cosine of beta. For sine, the formula is intuitive: minus here, minus here. Then cosine of alpha, sine of beta, right? This is a formula that you will find here. In case you forgot, is here: sine of x minus y, sine of x cosine of y minus cosine of x sine of y, right? That's what I wrote there. All right, so go ahead, use these two guys and express this in exact form. And in the end, you have to factor out the square root of 2 in order to see it among the choices, okay? In the end, factor out the square root of 2 over 2. Yeah, very tricky, this question. Uh-huh. Uh-huh. Let me check. Kang. Yeah, Kang. Very good. Excellent. Excellent, Kang. Yeah, you got it. You got it. Very good. Very good. Excellent. Excellent. Yep. Great. Great. Yeah, it's just a little trick in the end. You must factor out the square root of 2, right? Because otherwise, probably you will not see it among the choices. And of course, the heat of the unit circle there, right, in case you need it, right? So, great. Okay, so let's do it together, right? So we can go over more examples. This, according to this formula that I wrote out here, should be just equal to sine of 45 degrees times cosine of 30 degrees, right? This is playing the role of alpha. This is playing the role of beta, right? For our formula. So great. Minus cosine of 45 degrees multiplied by sine of 30 degrees, right? Now, sine of 45 degrees, we just saw it before in our unit circle, is a square root of 2 over 2, right? Great. Cosine of 30 degrees, also we saw in our unit circle, is just a square root of 3 over 2, right? If you want to double check, always you can go there to the unit circle. These are the guys from there. Minus cosine of 45 degrees. 45 degrees is a very easy angle to deal with, right? Sine and cosine are the same, right? The same. And it's in the unit circle anyway. Great. And sine of 30 degrees is just 1/2, right? 1/2. Yeah, sometimes, guys, you need to memorize this because you're going to use so much in Calculus 1 that it will be worth it to memorize it. But if not, it's not a problem. It's always in our unit circle, right? You can always look there. All right, and then the rest is to the math, right? But when you do the math here, this is going to be square root of 2 times square root of 3 square root of 6, 2 times 2, 4, minus a square root of 2 times 1 is just a square root of 2 over 2 times 2, 4. This leads to this, right? Square root of 6 minus a square root of 2 over 4. Professor, it's not there, this answer. Well, it will be there after you factor, right? After you factor. So factor out a square root of 2. Yeah, be aware of this factorization, guys. So a square root of 2 out And then you do this, right? The 4 will stay as 4 in the denominator, but you do this. A square root of 2 into the square root of 6, right? 2 into 6, 3, right? There's a radical there, so the square root of 3. Minus, minus. A square root of 2 into a square root of 2 into itself. This division is just 1, right? So this. And when you look at this form, this factor form, it will be there. It should be there. It's this, right? You see it, guys? Yeah. Sometimes the students, when they don't find this answer, they multiply this out, all the choices, and they compare. That also works. Whatever works for you guys, you should follow, right? We are getting ready for our final. Any method that works for you, use it, use all your knowledge, right? And get things done. All right, great. So now let me talk about this other form, which is a little bit longer than this. And let me give you an example so you will be ready for these forms. So going back to a lecture here, suppose they ask you this question. Given sine of alpha equal to 3/5 and alpha between 0 degrees or 0 radians, better said here in this context, and pi/2 radians, meaning this guy in the first quadrant, right? And then cosine of beta -5/13, and beta is between pi and 3 pi/2 radians, meaning on the third quadrant, right? Find cosine of alpha plus beta in exact form, right? So let's see how we can go over this. And then I will let you do something on your own. Okay, first thing you do here is this. Right away, try to see where the angles are. This one tells me that alpha is in quadrant 1, right? Alpha in Q1. And here, this is saying that beta is in quadrant after pi, before 3 pi/2, quadrant 3, right? Very good. Yeah, we have both. Next, write out the formula for cosine of alpha plus beta, which is this, right? Cosine of alpha multiplied by cosine of beta is counterintuitive, the formula for cosine. So this is plus, you expect plus, is not plus, is minus. Minus sine of alpha, sine of beta, right? Professor, where is the formula? It's here, guys. In case you forget, you have memorized that, it's here. I'm using cosine of x plus y, cosine of x, cosine of y, minus sine of x, sine of y, right? Sine on the top goes with sine on the top. Great. Now in this formula, identify what you have and what you don't have. For example, here, notice this cosine of alpha, we don't have, right? We don't have. So put a question mark. We don't have this guy. What about cosine of beta? Cosine of beta we do have, it's there, right? So check. Sine of alpha is also here given. So this we have. Sine of beta we don't have. We have to find the right question mark. So now I'm aware what I have to find. So now I can complete the sort of the ingredients of this formula. If you look at the recipe, right? And then we will be able to get this value, right? So let's do that by part. Let's first work with alpha. And I use blue. Alpha is in Q1, right? We just determine that from here, from this condition, in quadrant 1. So what you can do is you can draw an XY coordinate system and set your angle there. Alpha is there. Alpha is in quadrant 1. And when an angle is in quadrant 1, really, its reference angle is itself, right? It's itself. So I'm going to work directly with this guy. They are saying, so alpha prime will be just alpha, right? The reference angle itself. So they are saying that sine is 3/5. We know from SOHCAHTOA that sine is opposite over hypotenuse, right? So make up a triangle here in the first quadrant where your opposite is 3 and your hypotenuse is 5. This base will be missing, but not hard to find it, right? Use the theorem of Pythagoras, 5 squared equal 3 squared plus b squared, right? 25 here, 9 here, 3 squared plus b squared. Subtracting 9 in both sides leads to 16 equal b squared, right? And finally, taking square roots in both sides leads to b equal 4, right? b equal 4. So we were able to find this guy right away. Put here, complete your right triangle, right? Good. Now that you have completed your right triangle, remember we are looking for cosine of alpha, right? Then you say, okay, then cosine of my reference angle alpha prime is equal to, remember cosine according to SOHCAHTOA is according to the cap adjacent over hypotenuse, right? So it will be adjacent 4 over hypotenuse 5. This is the cosine of my reference angle, right? But then cosine of the actual angle, which is itself, because in the first quadrant, the reference angle and the angle are the same, right? Then cosine of alpha will be the same, right? It will be 4 over 5. So now I have found this guy, right? Check here, right? What is missing? Now I have to find this sine of beta, right? Sine of beta to be able to compute this formula. So let's do that. Now, beta, let's separate this. Beta is in Q3, right? Professor, how do you know beta is in quadrant 3? Because of this information. Bigger than pi, pi is here, right? Less than 3 pi over 2 is on the third quadrant. Great. So now we're gonna draw XY coordinate system, and we're going to represent our angle beta somewhere in the third quadrant. Let's say there, somewhere there. This is beta, right? So now allow me to construct a right triangle here to do the same, or better say something similar to what I did here, right? But now notice I'm in the third quadrant. So this is the angle beta, really the whole thing, right? But this one here, the small angle, the acute angle is the reference angle beta prime, right? I gotta work with this beta prime. Notice cosine of beta 5 over 13, cosine is adjacent over hypotenuse, right? So make up a triangle where the hypotenuse is 13 and the adjacent 5. Adjacent now here, right? 5. The opposite, we don't know. Let's call it A. We don't know, but not difficult to find what's the value of A. Applying the theorem of Pythagoras, right? A squared plus 5 squared equal 13 squared. Move it down. 5 squared is 25, right? 13 squared, guys, 169. You can check it in your calculator, it's 169. But what's important here is that when you subtract 25 in both sides, you're gonna get, after canceling this, that 8 squared is this number 144, right? And when you take the square roots in both sides, the square root of 144 is 12, right? 12. And again, guys, if you have difficulties computing these values, use the calculator. For example, square root of 144 is indeed 12, right? Great. Okay, now that you found this angle, not this angle, this side, the length of this side, right? Just place it there. This guy, we are saying, is equal to 12, right? 12. We have completed this right triangle, right? So now we are looking for sine of beta. So now when we say then sine of beta prime first, the sine of our reference angle, right? The angle that is in here, this right triangle. What's that? Well, it's equal to opposite over hypotenuse. Opposite we're saying is 12. 12 over hypotenuse 13, right? That's the sine of our reference angle. But now, what should be the sine of our actual angle. For that, I know that in value, this will be 12 over 13 because the reference angle and the angle itself, they have the same trigonometric functions in value, right? In absolute value, but the sine, I have to find out what it is. Not a problem, guys, because we have this nice mnemonic device. All students take calculus, right? Take calculus. And according to all students take calculus, only tangent and cotangent are positive on the third quadrant. So therefore, sine must be negative, right? Must be negative. So sine of beta, this guy that we're looking for, is negative 12 over 13, okay? So we got this guy. We got all the ingredients for our recipe, right? So then you just go ahead and do the computation, the final computation. I'm gonna do it here. Look, cosine. Then final computation, cosine of alpha plus beta will be equal to what? Cosine of alpha that was given, right? The cosine of alpha. No, it wasn't given, but we found it right here. 4/5, right? 4/5. Let's write it. 4/5, right? Within parentheses, okay? Times cosine of beta. Cosine of beta was given is here, minus 5 over 13, right? Pick it up from the body of the word problem, minus 5 over 13. Then we have minus sine of alpha. Sine of alpha was given 3 over 5, minus 3 over 5, then times sine of beta. Sine of beta, we just found it here, that is negative 12 over 13, right? Be careful with the signs, guys. All right, and then this, you can compute it this way. First, I will show you manually, and then I will show you how to do it with a calculator. If you decide to compute this in your mind, you should multiply 4 times negative 5 minus 20 over 5 times 13. 5 times 13 is 65. Minus and minus is plus. 3 times 12 is 36 over 5 times 13, 65. Then simply do this, right? Minus 20 plus 36 is just 16, right? 16 over 65. Great. This should be the final answer, right? That is what they were asking. Now, if you want to compute this whole thing in one computation using the calculator, I will show you now how. You bring out your Desmos scientific calculator or any scientific calculator of your choice, and you should do this. Parentheses, 4 over 5, close parenthesis here, times parentheses, negative 5 over 13, right? Come out there, parentheses, minus 3 over 5, close parentheses, times negative 12 over 13, right? Close parentheses, and you can see that the answer comes up by default in the Desmos scientific calculator as a decimal. This time, I don't want the decimal form, I want the fraction form. So just convert it to fraction here. Our scientific calculator has that option, right? Convert, and there you see 16 over 65. You follow, guys? I'm giving you these two methods because sometimes the computation may be reasonable. You can do it mentally, but sometimes you may have to use the calculator, okay? So consider that. So, but what is important is you get this as your final answer. That's it. Very good. Okay, now I want to show you an exercise here for you to do. So then we will do it together. So try to practice with this. I think it's, yeah, here. I'll give you a hint. Can you figure this out? Number 6. Number 6 is saying tangent of alpha is, I'm going to make it a little bit bigger. Tangent of alpha is 3 over 4. Okay. And alpha is between pi and 3 pi over 2, meaning alpha is on that in quadrant 3, right? alpha in Q3. Cosine of beta minus a over 17. Beta is between pi over 2 and pi, meaning beta in quadrant 2, right? Compute sine of alpha plus beta, right? And I'm gonna give you this hint also, right? Sine of alpha plus beta is equal to sine of alpha cosine of beta plus intuitive formula, right? Cosine of alpha sine of beta. Notice, right? We have cosine of beta. We have this guy. We don't have this, right? Sine of alpha. We don't have cosine of alpha. And we don't have sine of beta, right? So the hint is try to work with alpha first and set it in an XY coordinate system. And alpha in Q3, right? And from there, try to see, following what I did before, right? The trigonometric functions of alpha, sine, and cosine, right? This is quadrant 3. So we're there, right? Work with the reference angle, right? This is your angle alpha, this whole thing. But you just work with alpha prime, just this, right? The reference angle, alpha prime. Try to make up the triangle. Tangent is, remember, opposite over adjacent, right? So opposite should be 3. Adjacent should be 4, right? Yeah, try to continue with this. And you don't know the hypotenuse, right? See there and find your hypotenuse this way, right? 3 to the second power plus 4 squared. Yeah, find the hypotenuse, then you get sine and cosine. Try to do the same for beta. Yeah, working with this triangle. And of course, then use all students take calculus also, right? For your science, all students take calculus. Aha. Very good, guys. Very good. Aha, Kang, very good. Kang was able to find C, right? Yeah, very good, very good. C is, yeah. Yeah, it is 5. Yeah, very good, very good. Yeah, continue, Kang, and find, do everything and see if you can end up with the final answer there. Let's follow up what Kang did, right? C squared equal 9 plus 16. Very good, Kang, is 25. And taking a square root, C equal 5, right? Square root of 25, 5. That should go here, 5, quickly. So this. Yeah, then we can compute probably sine and cosine now, right? Using this triangle, right? Yeah, start by saying sine of alpha prime opposite 3 over hypotenuse 5. Therefore, sine of alpha, then here, right? Then sine of alpha, 3 over 5 in value, but using SOHCAHTOA, here only tangent and cotangent are positive, so this should be negative, right? Yeah, very good, very good, very good. Yeah, the same way, find cosine. We start with cosine of alpha prime, which is gonna be 4 over 5, and figure out cosine of alpha. Yeah, go ahead. And continue with the search for sine of beta, right? You gotta do something similar there. Yeah, let's just complete this. According to all students take calculus, only tangent and cotangent positive on the third quadrant. So this should be negative, right? Negative 4 over 5. So with this, we got this guy, sine of alpha, and we got this guy. So the only thing is to left is to find sine of beta. Do it here. Beta in, where is beta? In quadrant. Beta in quadrant 2, right? From here. Q2. So draw an XY coordinate system and set your angle beta to be here. This is the whole angle beta, but in reality, we just have to work with the reference angle, which is the acute angle formed by the terminal side and the x-axis, right? So work with this triangle base. I'm gonna use this color to indicate that you have to work here. Work with this. You know that cosine is adjacent over hypotenuse, right? So your adjacent should be, let's take it from there. Yeah, your adjacent should be 8, right? So 8 here. And your, adjacent 8, let's use this color, 8, and your hypotenuse 17, right? 17 here. So find this guy, let's call it A. Using this, A squared plus 8 squared equals 17 squared, right? Once you find A, then you can find sine of beta, right? Yeah, go ahead. And once you find sine of beta, you will have this guy, you will have all the ingredients for this formula, right? If we look at this formula as a recipe, right? Yeah, so find this guy, and then that should be the end. See some activity in the chat room. Let's check number 6. Kant has found the value of this A, right? Very good, Kant. Very good. Excellent. Yeah, very good. Very good. Yeah, let's go there then by part. Yeah. Okay, so A squared plus this guy 64 equals 17 squared, but 17 squared is 289. Professor, could we check? Oh, sure. If you are not sure about some computation, guys, you should calculate 17 squared, 289. Right? Great. Now we subtract 64 in each side. We're gonna get that A squared equal, this is 5, this is 2, right? And when you take the square root of this guy, believe it or not, guys, this is just 15. Can we check, Professor? Yes, sure. The square root of 225 is 15, okay? Great. Now, this 15 goes quickly here. This guy is 15, right? This A, 15. Right? So we got the value of A, right? 15. So then we can say, right then, we are looking for sine of beta, right? So let's start by writing out what should be sine of beta prime. Sine of beta prime, sine of our reference angle here, the acute angle formed by the terminal side of beta and the x-axis is just opposite 15. 15, this 15, right? Opposite 15 divided by hypotenuse 17, right? 17. This is the sine of our reference angle. But what should be then the sine of the actual angle? The reference angle and the actual angle, they have the same trigonometric functions in absolute value, right? The sine may be not the same. So we have to go through our mnemonic device. All students take calculus to figure out what is the sign of this trigonometric function, sine of beta. We are on the second quadrant. Remember, this says, all student calculus says, sine and its reciprocal cosecant are positive, the rest negative. This is sine, so this is saying it's positive, right? So here plus. Okay, we got this guy, right? We just got it. So now just put everything in and do this computation, right? This final computation. I'm gonna do it here, okay? I'm gonna say, okay, this guy will be equal to, or maybe we should do it here so here I can follow. This guy will be equal to what? Sine of alpha. Sine of alpha is equal to, we got it here, -3/5, right? So -3/5. Multiply by cosine of beta. Cosine of beta, it was given, is here, -8 /17, right? Good. Plus cosine of alpha. Cosine of alpha, we found it here, -4/5, right? Multiply by sine of beta. Sine of beta was the last value that we found here, positive 15/17. I don't need to write the sign. I just write 15/17, right? But now I need to do this computation. This time, I'm going to use the calculator and we're going to compute it. In one computation, we're going to get this value, okay? Look, calculator here, parentheses, -3/5, first factor, right? Multiply by, come out here, multiply by what? -8/17, right? Come out, close parentheses, plus, parentheses again, -4/5, 4/5, come out, parentheses again, 15/17, right? 17. Do this carefully, guys. This is what I get, this decimal value, right? Negative, but I want not the decimal value this time. I want the fractional form, right? So clicking here, convert to fraction, -36/85, right? And that's what you choose here, right? You follow, guys? -36/85. -36/85. Okay, great. That's it. Very good, very good. Let's talk about the formula for tangent. We saw formulas to deal with the sine and cosine for the sum of two angles or the difference of two angles. Let's talk about tangent of alpha plus beta and tangent of alpha minus beta now. The following formulas can be used to calculate tangent and cotangent of sum or difference of two angles. Mathematicians figure out that tangent of alpha plus beta is tangent of alpha plus tangent of beta all over 1 minus tangent of alpha multiplied by tangent of beta. And similarly, it's okay. Okay, similarly, tangent of alpha minus beta, tangent of alpha minus tangent of beta all over 1 plus tangent of alpha tangent of beta multiplied, right? Now, these formulas are very symmetric, plus here on the numerator, very intuitive, but on the denominator, kind of counterintuitive, right? And here is switch. If you are good at memorizing formulas, you are welcome to memorize the formulas. But if not, guys, that's not a problem because you have this sheet where they are all written out. Look, tangent of x plus y, tangent of x plus tangent of y over tangent of 1 minus tangent of x tangent of y. The signs on the top go with the signs on the top, right? And similarly, tangent of x minus y, tangent of x minus tangent of y, follow the signs on the bottom, over 1 plus tangent of x times tangent of y. The two formulas are compactified here, right? Good. All right, great. So let me show you an exercise so we can move on to the next section. Suppose they say, given that the tangent of u is equal to 5/12, find the exact value of tangent of u plus pi. Okay, so if you're asked to this, I would say simply write out the formula for tangent of the sum of two angles, right? So you will say, okay, tangent of u plus pi is simply tangent of u, if you take this u as your alpha, right, plus tangent of pi, if you take pi as your beta, right, in this formula. I'm using this formula, guys, all over 1 minus tangent of alpha, which is u, multiplied by tangent of beta, which is pi, right? Pi. Good. We just apply the formula. Now, tangent of u is given, is 5 over 12. So let's just replace it there, 5 over 12, plus tangent of pi. Recall, guys, what is tangent of pi? Well, it's sine of pi over cosine of pi, right? And on the unit circle, if you look at the coordinates of this guy, where pi radians ends, right, is minus 1,0, right? So sine is 0, cosine is -1. So 0 divided by -1 is just 0. Tangent of pi, guys, believe it or not, is just 0. It can be gotten also in the calculator if you prefer. All right, so this 0 over 1 minus tangent of u, 5 over 12, times tangent of pi, 0. 0 multiplied by any number is 0, so this part disappears. So this 0 added to any quantity is just the same quantity, right? 1 into any real number is just the real number itself. So we end up with this 5 over 12, right? So there you go. This is a little application in case you deal with this, right? In case you deal with this. All right, let's go back to the worksheet to see if we have exercise there. Otherwise, we'll just move on. Tanya here. You have here another one. Yeah. Can you simplify? Can you try this? Tangent of x minus pi. Simplify. Hint. Tangent of alpha minus beta from our sheet, which is together with the unit circle, right? This is tangent of alpha minus tangent of beta over 1 plus tangent of alpha, tangent of beta. Use this formula, guys, and try to figure out what this is. This is going to play the role of alpha. This guy is going to play the role of beta, okay? Follow this and see what you get, right? And try to identify the simplification of this. Then we will move on to the next section. Okay. See. Okay, let's work this out together, okay? Applying this formula, this should be equal to tangent of alpha, but alpha is x, right? Tangent of x minus tangent of beta, but beta is pi, tangent of pi. And remember, we computed this tangent of pi before, right? Yeah. 1 plus tangent of alpha, tangent of x, multiply by tangent of beta. Tangent of beta is tangent of pi. Now, recall, we just showed this, right? That tangent of pi is just 0, right? 0. I showed you this before, right? Before, because it's sine of pi over cosine of pi, 0. So substituting 0 there, let's see what happens. Tangent of x minus 0 over 1 plus tangent of x multiplied by 0. 0 disappears here. 0 times this guy 0. Tangent of x over 1. This is just tangent of x, believe it or not, guys. So tangent of x. Yeah, there's a surprising result here, but this is it, right? Excellent. Okay, in case this appears, this is how you proceed, right? Very good.